Hello and welcome to the fifth video in the series. In this video we're going to be focusing on the Fourier and sine series fitting functions. Real quick, this video is probably going to be long, but we're covering some pretty difficult topics here, so I'm going to try to explain what I'm doing in the best possible way, and that's the reason why it's going to be so long. I apologize in advance. Let's get started. So what is the Fourier Fit? So the whole goal of this tutorial here is to learn how to fit or curve fit functions. And in Python we can use the SciPy optimization library to fit any function that we want. We can literally build a custom function and then use the library to fit the parameters in our function to the data. So what we're going to do is imagine that F is our detrended price data, okay? And imagine this is just for our model. So there's a difference between, so imagine that F is the detrended price data, but that's in reality, and then X is hours in reality. But imagine that we also have a copy of this where F is just a model and it's equal to this. So what we're trying to do is we're trying to fit A1, A0, B1, and omega so that when we plug in X values here, or hours, that our model F is as close to the F in reality as possible. So that's what we're doing with a curve fit. We're trying to make these parameters such that this value is as close to the detrended prices as we can get. Okay? And so this is called a Fourier, I believe this is a first order Fourier expansion. Don't quote me on it. I just remember that from engineering class, but I'm not an expert on it, so don't ridicule me and burn me on the stake for it. Alright, so then there's the sine series, which is very similar, except we don't have the A0 term, or the A1 term, which is the cosine term. So the same thing here. We're just going to be fitting this function, trying to find those parameters. Alright, and you may be wondering, well, what's the method by which we're going to do this? So imagine that we have a data window. Okay, so imagine we have a 3-point window. And these are our price data. Okay, each one of these represents a currency exchange rate and an hour. Okay, and so imagine we take a window, 3 hours, right? So we take this 3 hours and we take it away, and we look at those 3 hours only. And what we're going to do is we're going to detrend it, we're going to fit the curve and find those parameters, and then we're going to store those parameters. Okay? So we're going to store, so these parameters for these 3 hours go here and they get stored there. Okay? And then we're going to shift it over, and we're going to store another one. And again, and store. So we're going to keep going through. And we're going to keep our iterator in Python is going to be this bracket piece right here. So imagine by the time we get to the end, we're going to be 3 from the end. So that'll come into play later when we're writing the functions. Alrighty, so let's get into it. The first thing that we're going to do is write the Fourier Series expansion fitting function. So the inputs are the same as the function. I'll pull it up on the screen right here. Okay, so what we're going to do is go ahead and write that function out in Python. A0, A1 times, and then we're going to use the NumPy trigonometric functions for this. So cosine and sine, we're going to use NumPy cosine and NumPy sine. Okay, so this is the Fourier Series expansion fitting function. And really fast, let's go ahead and copy and paste this guy. We'll put him right here, and now we're going to do the sine series, and I'll put that equation up. So with the sine series, we have no, let's see, I believe it's A1. So we don't have A1. So we can get rid of A1. And again, get rid of A1 down here. And so it's easy as that. So now we have our Fourier series and our sine series functions. Now what we're going to go ahead and do is write the function to go ahead and loop through and find all the parameters. Okay, so I've set it up in the standard way. Okay, so the inputs are prices, which is the OH open, high, low, close data, and then a list of periods for which to compute the coefficients. Okay, so this is going to be a list. Okay, like 3, 5, 10, so on. Okay, and then the method, and this is the method we're going to use to detrend the data. If you remember from the last video, we did a detrending function, and we're going to pass that method in there. Okay, and then we have we're going to return addictive data frames containing coefficients for the said periods. All right, so let's get started. First, I'm going to do this. Okay, so that's just an option that we're going to use later to demonstrate how this function works. So just put that in there and I'll demonstrate what it is later. So now we're going to compute the coefficients of the series. And the first thing we want to do is detrend the series. And you notice here that we pass in method. Okay, and method's just going to come from this argument here. So it's going to get passed in automatically. All right, and so now let's create an outer loop. So first we're going to loop through the periods. And for each period, then we're going to get the coefficients. Okay, so think of the periods as that window that I showed you in the PowerPoint. That window, see, we did 3 as the window in the PowerPoint, but we want to make the function robust enough to handle many different periods. So that's what we're going to do, is we're going to loop through all the different periods that we decide to calculate for, and then we're going to enter an inner loop. So this right here is going to loop through the periods, okay? So we're going to start at 3, we're going to go to 5, and then we're going to go to 10. And then let's initialize a list, an empty list, to store the coefficients that we find. And then we're going to enter the inner loop. So the inner loop, we're going to loop through the data frame. Okay, and I've set it up this way because what we want to do is, if you remember when I said you'll remember this later from the PowerPoint, when we reach the end, we will be the length minus periods. The period that we're looking at will be that amount from the end. So it will be this amount from the end right here, okay? Minus periods I. So when we're looping through, we want to go from periods I to the length of prices minus periods I. Okay, so now let's make some variables that we're going to use for fitting, or some data that we're going to use for fitting. So for x, it doesn't matter what we do, because we're going to be fitting x and y, where y is the detrended data. So x is not going to matter. So we'll just do this, okay? X is going to be 0 through periods of I using the arrange function. So we'll get 0, 1, 2, 3, 4, all the way up to periods. For y, we're going to do this. Okay, so this right here is that shifter. And I'll pull that up on the screen right now. So that's that shifter, okay? So when J starts off as periods I, J minus periods I will be 0. So that means we're going to start at 0 for the detrended. And then we're going to go through J. And J starts out as periods I. So the first time through, we're going to go from 0 to periods I. The second time through, we're going to go through 1, from 1 through periods I plus 1. Okay? The second time we're going to go through, and we're going to do from 2 to periods I plus 2. So that's that shifter right there. Okay, the next thing we're going to do is this. Okay, so what this is going to do is, this is a little filter that I've constructed, because, and we've imported this from the Optimize library from SciPy. And I told you guys to import this earlier because it would be easier on you to do it then, instead of wondering what it is later. Okay, so what this is going to do is, We're going to try to do the curve fitting now from the SciPy optimized package, but the SciPy optimized package may not be able to complete the curve fit. And if that is the case, if it cannot curve fit, it will throw an error for us. But we don't want that error to hang up our program, so we're going to implement this to catch the error and ignore it, okay? And then what we'll do is we'll set like not a number data for the results of those coefficients if we cannot fit the curve. So first off, so we're under with right here, so we're going to try. So this is what we're trying to do. And we're just going to call it res for results, and we'll scipy.optimize.curveFit, right? And then we want to put in the function, and our function is F series. That's the function we're fitting. And then the x data and the y data. And this is our x and y data right here that we're trying to fit. So x, y. Okay, it's that simple. And then we're going to say except, and if this occurs, then we're going to say result is equal to numpy.empty, and we're going to make it the size of how many parameters we have. So 1 by 4, because we have A0, A1, B1, and the frequency. So that's 4. Okay? And then we're going to set all of those equal to numpy.nan. So we're going to do that using this. Okay? Okay, so that's simple enough. So let's drop down outside of the width, and now let's plot it. So now we're going to create our data to plot the results of our fit. So to do this, we're going to use numpy.linspace. So this will create evenly spaced data from 0 to periods I. So we want 100 data points. So that'll give us 100 data points between 0 and whatever our period number is. Okay? And then yt is equal to f series, right? So this is going to be the value of our f series function at each xt. Okay? So we have xt, and then we'll do res 0, 0. Okay, so that's A0. Res 0, 1 is A1. Okay, and then we're just going to fill in the rest sequentially. I think you guys get the point. Okay, so this one's going to be 2, and this one will be 3. Okay, and then we will do plt.plot, and we already have x and y, so we're going to plot those first, and then we're going to plot xt and yt. And let's make this one red so we can see the difference. And then plt.show. Okay? So now that we have that done, let's go ahead and store our coefficients. So we have that empty list up here, so let's append to it. And what are we appending? Well, we're appending that first row of the results, okay? Which is all the values. We want to do it along the 0 axis. Okay, so now let's drop out of the inner loop. So now we are outside of the inner loop, and we'll do this. Okay, so this is going to filter out the visible deprecation warnings, and this is because something that I'm doing in here is NumPy does not like, and they're going to change it in the future. But I like it set up the way I have it, so I ignore those errors, and it won't stop the program. But it's a warning that I just don't like, so I just get rid of it like that. So moving on, now we'll store our coefficients. We'll make them into an array, and then we'll reshape the array. So we'll store it in an array first, and then we'll do reshape. So we want it to be in the shape of 4 columns. Each column will be a different parameter that we found, and then each row will represent the different hours that we've calculated them for. So to do that, we'll do, first off, we'll do the length of coefficients divided by 4, and that's how many rows we want, and then we want 4 columns, okay? So that'll give us that, and then we'll store it in a data frame, okay, with an index. So we want the index to be from prices, and we're going to go from periods I through minus periods I. And again, oh, not capital I, little I. Okay, so this should ring a bell again because this is very similar to what we did up here, where we want this to be the similar, okay? It's very similar, these two things. Okay, so that should make sense if you think about it a little bit. And now we'll set the column names to be what they should be, the names of the parameters. Okay, and then lastly what we'll do is we want to do something about these NaN values because more than likely we will encounter these NaN values. So what we want to do is use a built-in method with pandas to get rid of them. So and that method will be fill_NA. So df.fill_NA and then method is equal to backfill or bfill. Okay? So what this is going to do is it's going to go through and for each not a number value that it encounters, it's going to set that value to the closest real number value behind it or above it in the series, okay? So after we do that, let's go ahead and store this data frame that we created right here. Let's store it inside the dictionary that we made with a key according to the period that we're working on. Because if you remember, we are still inside this loop right here. You can see this line that comes down. We're still inside the loop. So we can still use periods I, so we'll use that as the key for our dictionary. And we'll set that equal to data frame, okay? So now each time it goes through, it will set a new key with a different data frame with different coefficients corresponding to that data frame, or corresponding to that period, okay, if that makes sense. And then we'll set results.coefficients is equal to the dict, okay? And then we will return the results. All right, so that is the big boy right there. That is the Fourier Series coefficient calculator. All right, so but we are not done with that one. But we're not done yet because now we need to make the sine series one. So what we're going to do is just a quick copy and paste. Whoops, hold up. Because the Fourier and the sine series are very similar, okay? So we just change this to sine, okay? And all of this is still going to pertain, almost everything here. Okay, we just need to change a few things. Like for instance, we're not fitting the F series anymore, we're fitting the S series. Okay, and if there's NaNs, it's going to be a 1/3 since we only have 3 parameters. And down here under plot, we're also going to get rid of one of these, and we're going to change this to S series again. We're going to keep going, keep going, keep going. Right here, we're going to change this to 3 and 3 because now we want 3 columns instead of 4. And then we don't have A1 anymore, right? So we're going to get rid of A1 when we rename the columns. And that is it. So this is the completed sine series and the completed Fourier series coefficient calculator. Okay, so now what I'm going to do is head over to tester. And what I'm going to do is I'm going to call the function. And we'll start with Fourier. And what I'm going to do is change this plot to true up here so that we can see the result of the fit so I can show you guys what it's doing. So let's just say f is equal to Fourier. We'll pass in the data frame. And let's just do like 10. Probably 10 and 15 as our periods. And then for the method, we'll do the difference method. And this is a default, so you don't actually have to specify this, but I like to do it anyway because it makes me sleep good at night. All right, so now that we have that, that will automatically run. Let's hopefully we don't have any errors. Okay, so right here, you can see the result of the fitting function, the Fourier fitting function. So this blue data is our actual data, 10 data points, because I specified the period as 10. And then this is our fitted function, okay? So if we click, if I close this, it'll open the next plot. So if you look, it's gonna add one more blue line on here to the previous one. Okay, do you see that? So you can see how the waveform, it's fitting up pretty nicely for the most part to the function. I mean, the function is fitting nicely. You can see this one is fit fairly nicely. So look at this. So it's very powerful, and it turns out that this is one of the best indicators. And let's just test out the sine. Let's test out the sine series fit just to make sure that one's working too. So change that to false. We'll scroll down here to the sine, and we'll set that to true. And then over here, let's just do sine instead, and we'll run this one. Make sure that one's working. Okay, so this is the result of the sine. So the sine is a more simple wave, and it's not going to be able to capture as much information. As you can see here, there's some of them that aren't very good. But for the most part, these are very powerful tools, and we will be using it heavily in the videos to come. So that is going to conclude the Fourier and sine series fitting videos. In the next video, I'm going to go ahead and start on the Williams accumulation distribution function, which is going to set the stage for the rest of all the future functions that we're going to make. So with that being said, I hope you guys really enjoy this. I know it's not the most exciting thing right now, but this is extremely powerful, and I'll demonstrate it to you guys later. If you guys enjoyed the video, go ahead and leave a like or subscribe. And I appreciate the effort. I'm having a good time making the series. You guys have a good one.